Hello everyone, how are you? I hope you all are doing well. First of all, please let me introduce myself. My name is Theo. Currently, I work for Airlangga University as a lecturer in robotics and artificial intelligence engineering. Well, okay. In this opportunity, I'm going to introduce you a project that we have started since 2020. This project created a device called AirFeel. But what is AirFeel? Let me tell you the background of the development of this device. Okay, in this modern era, the awareness of utilizing renewable energy has dramatically increased. According to zerocarbonanalytics.org, many countries across the world have scaled up their renewable energy capacity in the past decade. And this is also happening in Indonesia. The president of Indonesia, Joko Widodo, inaugurated the largest floating solar power plant with a capacity of 192 megawatt on November 9th, 2023. This power plant is situated at Cirata Reservoir, West Java. Just the photo you see on the screen. This is the photo of the floating solar power plant at Cirata Reservoir, West Java. Okay, here I show the capacity estimation data of renewable energy in Indonesia. Uh, According to Institute for Essential Services Reform, or as known as IESR, the technical potential of a solar power plant reaches up to more than 7,000 gigawatt. Yeah, this huge number is based on calculation of available areas that can be covered by solar panels, like on the rooftop, on the ground, and also on the water. But if we look at other data, the General National Energy Plan in Indonesia, we call it as RUEN, RUEN, says that the potential of uh, solar power plant is 208 gigawatt. Yeah, we see there is a big difference between these two data, yet still solar energy provides the largest energy source among the others. And Rowan also puts onshore wind power plant in the second place, as it generates 60.6 gigawatt of energy. That's really huge. So, what is the correlation with our product? In this case, the development of a renewable energy power plant, we need to do some analysis in the area where we want to build the power plant to see how much energy will be produced in a certain period of time. So, um, a time series data is essential to be collected for examining the production capacity. Let's say for a year. But uh, how can we do that if the candidate site is really far away from our office? Yeah, here is how this idea takes place. Okay, as we can see here, this is the photo of 5.4 kilowatt peak solar panels. This solar panel is installed in our campus, just behind of my building, and it is used for charging station for electric car, uh, you can visit this place when you are here. All right. So AirFeel. This is the name of uh, our product. AirFeel is an IoT-based weather station system which has two sections. There is a field station and base station, and it is equipped with several sensors. After it is properly installed, this device takes some data of the ambient condition. For example, solar irradiance, the level of several gases like carbon dioxide, oxygen, carbon monoxide, uh, and wind speed, rain gauge, temperature, humidity, and air pressure. Those data are really important parameters to examine the potential of renewable energy source in particular location. So, uh, uh, this is the diagram I have mentioned earlier. There are two sections of airfield. This is the field station, and this is the base station. So, how it works? Airfield has uh, two microcontrollers uh, here in the field station. Uh, Microcontroller is a programmable device that runs some tasks given by the user or the programmer. So in this diagram, we see two microcontroller boards that handle different tasks. Here, the first microcontroller board collects data from various sensors. Uh, Here are the sensors. Then, after all the data are collected by this microcontroller, and here we see anemometer, something that measures the wind speed, the wind vane. The wind vane will indicate the direction, the wind from where the wind is coming. The rain gauge will measure the rain, then temperature, humidity sensor, barometric pressure sensor, and etc. So after the data are collected by this microcontroller board, the data will be sent to the second board through serial communication. And then this second board will store the data to the SD card. Uh, I think you are all familiar with SD card, a memory card that is also installed in our mobile phone today. And uh, apart from that, this microcontroller also upload the data to the online database. So every single authorized member out there can access to this database and do analysis. Uh, we also developed a mobile app to see the measurement results online. Thus, by using AirFeel, it is possible for us to retrieve uh, the ambient condition where the device is installed all year round. This data would give us a valuable insight related to its feasibility of becoming the solar power plant site. Uh, all right. Here is one of the devices that has been installed at Giliang Island, Madura. Giliang is an island that was recorded to have highest oxygen level in Indonesia. And you're gonna visit that island. As we can see here, Airfield is powered by a 50-watt solar panel and one battery 12 volts, 18 ampere hour battery. The energy stored in this battery will power up all electronic devices here inside of this box. This is the microcontroller I mentioned earlier. It is so compact, integrated, and small sized. And at the outside here, we got rain gauge, and then solar irradiance sensor mounted on the blue plate here, anemometer for measuring the wind speed and wind vane, and this will indicate where the wind direction is coming. So the readings from all sensors are sent to the microcontroller here inside inside of this box to be uploaded to the online database through internet connection. That's why Airfield is IoT based, because this device is connected with internet connection, and then someone out there anywhere in the world, as long as you have internet connection, you can access and you are authorized to access the database. You can see the data that has been uploaded to the database. It's very simple, yet it gives us valuable data. So prior to the installation, we tested and characterized the sensors to assure that they will give us a reliable values. This is the photo of a test we carried out in the lab. As I showed you the diagram earlier, the data reading can be displayed uh, throughout an app, something like this. We can read the level of CO or carbon monoxide here, carbon dioxide here, the humidity, the temperature, the wind speed, and in the middle of this image indicates the wind direction and its speed. And here on the right side, we got the solar irradiance. We see that the solar irradiance fluctuates over time. Yeah, that's uh, pretty normal, and we can collect this data throughout the year, all year round, because the device uploads the data to the database. And yeah, here is the different version of Airfield and its data display here. This is the coming from Airfield version 4. Uh, the indicator just the same, but we change the color and etc. We can see the data real time. Well, we do not stop improving every day. We always look for better usage of this device, better data processing, better data interpretation. Uh, Hopefully, we can contribute more to the growth of renewable energy development, specifically in Indonesia. All right. Um, yeah, I think that's all of my presentation. Thank you and see you again.